like the group week 14 problems, and I was like, I could just finish them and be done. But then I was like, I don't want to.
I've been trying to balance everything, so I have a few of them done
You've
with
done it?
heavy.
I've done the first one, but that's it. I went to the second one, and there was like actual math required, so I was like, no.
Matt, who needs it right now?
Exactly. Yeah. If there's math in it, I'm like, I'm not gonna do that. All right. If you want to start, or would you like me to start?
Do the one you have, and we can go
Oh,
from there.
no, I have them all. I was talking about week
Oh
14.
yeah.
I have them all. Yeah.
Oh,
No.
week 4. Oh, my bad. Okay. No, I
I,
only have a few on. Ay,
that
ay, ay.
which ones do you not have?
So I started working on 5,
Hmm.
and I'm about done there since it's just that equation.
Yeah.
So I just need to plug in the numbers there and pop that out. So I don't have 6, 7, 8, and 9.
That's fine. I can turn in those ones because they were like the same thing. You put it in an equation and it was easy. All
Oh,
right.
really?
Why don't you start with 1? And then we'll just have you turn in your first page and I'll let you know what I got for 5 to make sure that we put in the same numbers.
Okay, sounds good. So for 1, for part A, I
Mhm.
used the equation F equals negative kx.
Yeah.
And so rearranging it, I have k equals negative f over x.
Yeah.
And so I did the 120 times the 9.8 over the negative 0.75 times 10 to the negative 2. And I got 1.57 10 to the 5th newtons per meter.
Yeah, that's what I got as well. For part B, I did the same F equals negative kx, except I replaced F with mg. And then I divided negative kx by g, so I isolated m. So then I had the negative 1,568 or 156,800, which is what I got in A, but I did scientific notation for the answer. And then I multiplied it by negative 0.0048 because that's centimeters instead of meters. I mean, that's in meters instead of the centimeters. And then I divided it by gravity, which gave me 76.8 kilograms. So they were allowed on the team because he's under 85.
Sweet. That's what I got.
Okay, perfect. What did you do for number 2?
So for number 2, I wrote out the equation on one side, said what each part was,
Yeah.
F, and so I said it is nearly empty because the frequency of oscillation and the mass are inversely proportionate to each other.
Yeah.
Therefore, a bouncing trailer is more likely to be nearly empty.
Yeah, that's what I said as well. For 3, so I used the equation F equals 1 over 2 pi multiplied by the square root of k over m. And then I did the equation F1 over F2, so it's like the same thing but on top of each other. And then I crossed out the 1 over 2 pi because it was a duplicate. And then I crossed out the k's over m1 and m2, so I ended up with just F1 over F2 equals the square root of m1 over m2. And then I multiplied by F1 to isolate F2. So then F2 was equal to F1 multiplied by the square root of m1 over m2. So then I had F2 equals 4 multiplied by the square root of 10 over 85, which gave me 1.3719, which I made 1.37 hertz.
That's what I got.
I'm like out of breath because I can't breathe through my nose right now, so I'm sorry.
It is winter time. I'm just waiting for my turn.
I know. I'm like, come on. Like, I feel totally fine. I just can't breathe through my nose, which sucks. All right. What did you do for number 4?
So for number 4, I wrote out the equation T equals 2 pi times the square root of lengths divided by gravity.
Uh-huh.
And said the length of the pendulum would need to be increased to match the acceleration due to gravity. This would equal the ratio of length to gravity of a place that had less gravity and a shorter pendulum.
Yeah. Yeah, I just drew the equation and then I showed like if you increase G, you're going to decrease L. And then I said, so you need to increase L to maintain your time period. So yeah, same thing.
Yeah.
All right, for K, I mean, I don't know where that came from. 5. I kind of did the same thing I did with number 2, where I put like the T1 over T2 with the 2 pi equals the square root of GL.
Okay.
And then I ended up I crossed out the L's because they have the same length. And then I had the period T1 over T2 equals 2 pi the square root of G2 over G1. So then I put in my numbers. So it was 2 divided by 1.99796 is equal to 2 pi the square root of G2 over 9.8. And then I solved for that, and that gave me 9.82002. So 9.82 meters per second squared.
So exactly what you did in number 2, pretty much.
Yeah.
Just different
Yeah.
variable.
Yeah, exactly. I can turn in a photo of this one if you want, or I can just read out to you what I got. What do you want to do? Or you have the numbers, right? You just need to plug them in at this point?
Yeah. I
Okay,
just need to plug it in. I have the formula. I just need
Alright.
to write it out and then
Okay, that's fine.
because I have what you have with the T1 over the T2
Yeah.
things. I just need to plug in the numbers.
Okay, perfect. That works. So then I'll just have you turn in the first page, and then I'll do the second page. I'll still walk you through it if you want me to. For 6, you just have to give an example of each. So for transverse, I said electromagnetic waves. And for longitudinal, I said sound waves. And then for 7, that was like you read the textbook and they gave you the answer. So
Love that.
And sometimes I feel bad. I'm like, I'm using the same example, but I don't really care. For 7, I use the equation velocity equals Fx. So I rearrange it so then I had frequency as V over X. And then I substitute in, so I have 3 times 10 to the 8th divided by 0.12, which gives me 2.5 times 10 to the 9th hertz. And then for number 8, so the frequency of the beat is equal to the absolute value of F1 minus F2. And then, so the F1 minus F2 is equal to the 0.500 hertz they gave. And then you have to find their frequencies. So I have the average of the two is F1 plus F2 divided by 2. And then for the average, I took the 0.5 and I set it equal to F1 plus F2 over 2. So it gave me 82. Wait, where'd my math go wrong there? Pause, please. Oh, that's
so times the other side
I wrote down the wrong number, but I did my math right. So the average was the 4,100 hertz equals the F1 plus F2 divided by 2. And then when you multiply 4,100, you get 82,000 hertz for F1 and F2.
Okay, I see what you did. Okay.
That one, like I wasn't sure how to do it for like the longest time because I was like, are they supposed to be different? And I don't know how you'd find that they were different unless they gave you more information. But I found like an example online where someone did something similar, so I was like, yeah, I'll roll with it.
I kind of don't like how sometimes they don't give you a whole lot of information. It's like, oh, I'll teach you like this. And then, boom.
That you're like, I think I'm missing something.
Yeah. And then they do it and it's like, what?
Yeah. That's how I feel all the time with like the individual exercises. I feel like I take 15 steps to get the right answer. And then I look at the solutions and they did it in like 2 steps. And I'm like, cool. That sucks.
We aren't in calculus.
I know. I'm like, this sucks. All right. For number 9, for part A, so what is the intensity? Intensity is equal to P over A, or power over area. So I did the 1W divided by the 0.05 meters squared, which gives me 20 W per meter squared. And then for B, I used the same equation, but I rearranged it to give me area equals power over intensity. And then it was A equals 1 divided by 0.1. So that gave me the area is equal to 10 meters squared. And then to find the distance, area is equal to 4 pi r squared. So I set the 10 meters meters squared equal to 4 pi r squared. And then that ended up being r equals the square root of 10 divided by 4 pi, which was 0.892 meters.
And that was just the radius, right?
Yeah.
So you have to times that by 2 to get the full distance?
No, because I think that's just like, because that then you'd be getting the diameter, but the speaker is sitting in like the middle, and so any distance is just going to be the radius in any direction. You know what I mean?
Okay, I got it. That makes sense.
Yeah. So that's what I did, because I did that at first, and then I talked myself out of it because I was like, do I need to multiply this by 2 or not? But then I realized, like, no matter where you are, like, as long
It's
as
the same
you're
distance.
in the center, you're going to be the same radius.
Okay, got it. That makes sense. That
Yeah.
makes perfect sense to me.
Good. All right, this week was pretty easy. I'm happy about it.
I wish they were all this easy.
I know.
It's like
Except I look like
first-
a TA and there's more questions than normal. I'm like, I don't like that.
How many is this week?
It's 9, but like the last couple of weeks have only been 7, which was so nice. But it's whatever. At least I'll live, even